Okay, everybody, welcome to week 3. We're going to work a little bit through section 7.5. A little different this time around because I'm going to actually kind of go through some of the MathLab and how that might be, how you can do some of that as we get into a little bit of graphing this coming week. So here's a sample problem. This isn't exactly one that you'll see, but it's very similar. It just wants us to graph an inequality. So it's stuff that we've seen before. But I kind of want to just go through little bits and pieces of what we're going to do. So here, as you see, the first problem that you see here is 5x minus y is greater than 10. And they're going to ask us to graph this. So what we're going to just go ahead and do is get it into y equals mx plus b form. So this is the one that we have. So what we see that we need to do, and I'll use my nasty handwriting here, is we want to subtract that 5x from both sides, which leaves us with a negative y greater than negative 5x plus 10, because that's a positive 10. That looks disgusting. And then now, since that's a negative y, we need to divide everything by a negative 1. And remember, when you divide by a negative, that changes the inequality. So this is going to be y is now less than a positive 5x minus 10. Okay, so this is the equation that we're going to graph. Now, since it's a just a less than sign, there's no line underneath it. If just less than, it means we're going to have a dotted line. So let's go over here. We're going to graph our line. So we're going to click a dotted line first, and it's going to be a line. We're going to make a line. That's where we're just going to click these. There's all kinds of different options. We have parabolas, we got circles. We're going to check those things out, but not yet. So the equation 5x minus 10, remember you always start at the y-intercept. That's this negative 10, and then our slope, rise over run, that's 5. So if I go back here, our y-intercept is at negative 10, the y-axis. And then we're going to go from there up 5 over 1. Click a point. That gives us our dotted line. And then one other thing is the fact that it's an inequality. We're going to have to shade. So since that's less than, we want to shade below the line. So we're going to click the little paint bucket. If this is our line, we want to shade underneath it, which is somewhere in this general area. And make sure that it is shading the underneath portion. Check answer. Well done. Let's go ahead and let's move on. So, next choice is a circle. All right, you can tell these are all circles. It says x squared plus y squared is less than 49. So if I go back here, this is the equation that we're looking at. This is the equation of a circle, okay? Where if it just says x squared and y squared, that means that our center is 0, 0. Remember, if there was parentheses, like if it said x minus 1 squared or something like that, then that would change these coordinates. It's always the opposite sign. So if it was x minus 1 squared, then that would be a positive 1 here. But there's nothing there, so then we know that that's 0, 0. All right, and then our radius, since that's a 49, we always need to take the square root of that. So our radius is going to be 7. So now when we go back to this, we've got multiple choice. We're going to have a circle that's centered at 0, 0, which is all of them, and a radius of 7, which appears to be all of them, because they all kind of look the same. So let's look at the other parts. It's less than. So since it's a less than, we're going to be shading the inside of the circle. Okay, greater than would be on the outside, because it would be everything on the outside of the circle. Less than is going to be on the inside. And then since it's a less than, no equal to, it's going to be a dotted line. That leads me to believe that C is our choice. Okay, dotted line because it's less than, shaded inside because it's less than, not equal to or anything. Okay. Next one, graphing the following inequality. Lucky for us, the y is already by itself. Okay, so what we're going to look at here, we're going to be graphing, since it's an x squared, that is a parabola. Okay, it's a parabola that's going up and down. Now, we know that a regular parabola would just be have a vertex at 0, 0. But this one is x squared minus 7. So we're going to go down 7. And then one quick thing that you could do is just go kind of up 1 over 1. And because it's just x squared, up 1 over 1 here. And that would click our, that would create the rest of our parabola because it automatically fills it in. Now, it is greater than or equal to, so we're going to have a solid line. And then since it's greater than, we're going to shade above that line here, okay, above the parabola. So it's going to be inside of here. All right, and we could just kind of click anywhere. It gives us coordinates. We could just click anywhere inside of the parabola. Now, okay, I just ran through graphing that. That's a little not as easy to do, just thinking, oh, hey, x squared minus 7. It's got to just be right there. So this is where you can have a couple options. You have your graphing calculator, okay, where you could go y and then x here. All right, there's your x button, squared, minus 7. And then take a look at the graph, and you can kind of be able to tell, all right, here's where some points are going to be. And use your table, okay, 0, negative 7. All right, remember, it's a table. You get second and then graph. 0, negative 7, that's the vertex because that's right in the middle. And then you could just click one of these other points. And the nice thing about this MathLab is it just generates the whole thing for you. You only need one other point. So as long as you get the vertex, which you can tell is the middle number. Look at the y's. It starts to repeat itself. There's a little pattern here. So the number right in the middle, that's your vertex. Use everything else to plot the rest of it. So if you don't have your calculator nearby, what else could you do? Well, let's open up a new window here. You could also use, where is it at? Desmos. Desmos is a beautiful thing. All right, will you go away? You could do, this is a little cheat code here, I know, but you can go y equals x, let's get up here, squared minus 7. And once again, here's your graph. 0, negative 7 is one of the points. 1 and negative 6. You could do 2 and what was it? Negative 3. Okay, that is not as easy to do. 2 point whatever that number. Okay, but at least you can kind of get the general graph. So, anyways, back to this. There's our answer. Once again, pay attention to solid line, dotted line, all that stuff. Now, this one gets a little bit tricky. We have a set of inequalities. There's multiple equations here. So what we're going to go ahead and do, I'm going to load up this thing again. Each of these, since there's no x squared, there's no y squared, nothing, we're going to have to get them into y equals mx plus b again. So the first one, we'll subtract the 3x. So negative 4y is less than negative 3x plus 12. You can hear the clicking. This is really annoying. Divide everything by a negative 4. So you get y. It's a negative 4 we're divided by, so switch that thing around. Y is greater than 3/4 x. And then 12 divided by a negative 4 is a negative 3. Nice and neat. Not. Okay, same thing here. Okay, subtract the 5x from both sides. So, what was that? Negative 2y is greater than negative 5x plus 10. Divide both sides by a negative 2 everywhere. Wouldn't it be sweet if I had like a smart board in my house? That'd be cool. Or like at least something to freaking write on. All right, so negative over a negative gives you a positive, 5 over 2. And then we have a minus. 10 divided by 2 gives us a 5. Here is both of our equations. Okay, so let's go through and let's look at this one more. Oops. Look at this one more time. Whoop, just realized I made a little mistake here. Let me go ahead and fix that first one, it's a line underneath it. Okay, so now let's go ahead and let's graph. So this first one, y is greater than or equal to 3/4 x minus 3. So let's go back to this solid line, and we're going to go to minus 3, that's our y-intercept, and then 3/4 up 3 over 4, there's our first line. Now when you take a look at it, it says greater than or equal to. So since it's greater than, we're going to be shading above it. Okay, so let's go ahead and let's shade above it just to kind of see what it looks like right now. And now, let's go back to our equation. Our second one, inequality, is less than 5/2x minus 5. So we're going to make a new line. It's going to be dotted. We're going to go down to minus 5, and then up 5/2. And then we want, since it is, I keep clicking on it, is less than. So when we take a look at the line we just made, we made this line shading underneath, which is this section that it is already populated. Now, if we didn't want that, you could probably clear it out. Oop, I made a mistake. I did not want to do that. Let's see what it says. Oh, it lets us do it. Okay, but that's what you want to pay attention to. Okay, this first line, the one that we did, the one that's solid, we shade above. But the second line is being shaded below. So you want to shade in the overlapping area. Okay, now this next one. Similar idea to what we just did. Both of these cases, we need to get y equals mx plus b. So we're going to subtract x from both of them. So the first one is going to be y is greater than negative x plus 2. And the second inequality is going to say y is greater than negative x minus 7. So both of these are greater than. They both have the same slope, negative x, negative 1, just different y-intercepts. So if you remember, same slope means they're parallel. And if they both say greater than, we didn't have to divide anything. Let's look back at the choices. We have, in both cases here, we are going to be shading above. So the part where they overlap, since both lines are shaded above, it's really hard to see this, but this is definitely not going to be the choice because this shaded area is below the blue line. This one, the shaded area is above this line. We don't see anything here because you want the shaded area to be where they overlap. So they're overlapping, they're both shaded above. It's going to be this choice because it can't be this one because the shaded area is below the pink line. And then similar in D, the shaded area is down here. Cannot be the ones that we were just talking about. So this is the only choice. All right, lastly, first thing is let's take a look. We have x squared plus y squared less than or equal to 4. So that is a circle where the center is at 0, 0. And the radius is the square root of 4, which is 2. Okay, that's the first thing. And it's less than or equal to. So it's going to be a solid circle, solid line, and it's going to be shaded on the inside. We'll wait to graph that. We'll graph that one in a minute. But the second part, y minus x squared, let's add x squared to both sides to get the y by itself, because we've already kind of graphed this before. So it's going to be y is greater than x squared minus 1. Okay, so this is going to be a parabola, and it's going to be shifted down 1 because of that minus 1. So let's go ahead, let's get this thing finished off. Here's our graph. First thing we'll do is our circle. Okay, we got a circle centered at 0, 0 with a radius of 2. I forgot to click it, but it is a solid line, so that's okay. And then we're shading on the inside of the circle. Excellent. Okay, now we're going to also do a parabola. When we take a look at the equation, it was just greater than. Okay, just greater than. So we're going to shift down. We're going to make it dotted. We're going to shift down 1, up 1 over 1, And then we see it is greater than, so it's shaded above. So it's shaded above the parabola, and it's also on the inside of the circle. Now, I'm going to clear this out. I probably should not have shaded yet. So if you don't shade yet, we have our circle. You make your dotted line parabola, and then from there, okay, needs to be above the parabola, but also inside the circle. That tells us that's the area that we need to shade. Check our answer. We are good to go. Okay. Please make sure you let me know whichever questions you guys have. Obviously, this was just going through the MathLab part. If you are doing your textbook work, it's going to be a little bit more drawn out, which could be a little bit easier to do if you're just kind of shading in pencil. But obviously, I felt like the MathLab was kind of tough to understand at times, so that's why I decided to go through it. But let me know whatever questions you guys have. I will do my best to answer it as quickly and as detailed as possible. So I will catch you guys all later, and have a great week.